Okay, so artificial intelligence, you know, it's still got this kind of sci-fi feel to it, don't you think? Like robots, you know, and all that. But it's actually already a part of our lives. It's kind of sneaky like that, like with streaming, and even like when your GPS tells you where to go.
Yeah, it's true. It is everywhere, isn't it? And I think that can be a bit intimidating, you know, all the technical stuff, and it feels like it's just going to keep changing. So what we really wanted to do with this deep dive is help everyone understand AI better.
Yeah, like think of this as like an AI tour or something. We're gonna make it clear, especially if you're new to all this. We'll go back in time and like tell the AI story.
Okay, and every story has a beginning, right? So let's start with what intelligence even means. It's about learning, picking up skills, and then using those to deal with anything, you know, without someone telling you what to do. Like just like how kids learn.
Right, like that ability to learn and change with new situations. So if that's intelligence, then how do we define artificial intelligence?
Well, you know, it's like this. AI is a part of science and technology, and it's all about making machines that can learn and think, as well as humans can. So giving machines that same ability to learn and use what they learn. So
it's not just like programming. It's really learning and thinking, like you said, and you mentioned a timeline. Where does AI even begin?
So it all starts with computers, right? If we didn't have computers and that ability to handle information, well, there wouldn't be any AI. And for the timeline, there are different periods, right? First, you have those early days. Those were all about what we call expert systems. Then things shifted. We got machine learning, and now we've got neural networks, and AI is making a comeback, big time. And it's all thanks to lots and lots of data. You know, the power of computers and some really clever algorithms.
Okay, so let's go back to the beginning. What was AI like in those early days? What were those pioneers trying to do?
Right. So back then, the main thing was expert systems, and the idea was you take what human experts know, right, and you put that into a computer program, but you use rules to do it. It's like making a flowchart. You know, if this, then that kind of thing, and the computer just follows those rules to make decisions. And this whole idea came from a group called the Symbolists. They thought you could make intelligence happen just by using symbols and logic.
So the AI wasn't learning from experience, really. It was just using what humans told it.
Exactly. Yeah, those systems, they totally relied on how good those rules were, you know, the ones made by human experts. And they were good at some things, like early medical diagnoses or, you know, games. But simple games, that is. The real world, well, that's a lot more complicated.
Yeah, makes sense. The real world's messy. So a bunch of rules probably wouldn't work for long. So what changed? Why did they move away from those rule-based systems?
Well, those expert systems, they just couldn't keep up, especially with those complex problems, the kind that are always changing. Just think about trying to put all that human knowledge into code and then keeping it up to date. It was too much. So that's what led to a whole new approach. We call it the learning wave, and it's all about machine learning.
Oh, okay. So this is where the machines start learning from their own experiences, sort of.
Yes, exactly. It's a big change. Instead of programming all those rules, you just give the system data, and the system, it learns from that data. It figures out patterns and relationships all on its own. And this was all possible because we started having so much data. I mean, everywhere, for everything. And the more data the system had, the better it got at seeing those patterns and making predictions.
Okay, I think I get it. So can you give me an example?
Sure. Let's take speech processing. Remember we talked about that. So with those old expert systems, you'd have to like make all these complicated rules, you know, based on how we speak and stuff to understand what someone was saying. But with machine learning, you can use some basic stats, right? Like different sounds have different statistical patterns, like shapes have different mathematical descriptions. But here's the key, right? The system learns the details on its own from all that speech data. It figures out accents and how fast someone's talking, even background noise, all without you having to, you know, program every single possibility.
Okay, so you give it some basic framework, and then it just learns the rest by looking at the real world through all that data.
Got it. So what was the next big step? So the next big thing was neural networks. And more specifically, deep learning. This is where things really started to change. Neural networks, they're inspired by the human brain. They have these interconnected units called neurons, and the connections between them, they're kind of like synapses in the brain.
Yeah, neural networks. We hear that all the time now. Can you explain it in a simple way?
Okay, so imagine layers, right? Layers of these nodes that are all connected. And the data, it goes into the first layer. And as it goes through each layer, it gets changed, with math and stuff. And each connection between those nodes, it has a weight. That weight, it affects the signal. And at each node, it also uses an activation function. And then through training, you adjust those weights and those functions, all based on the data. And that's how the network learns, It can figure out really complex stuff and then give you the right answer.
Yeah.
And deep learning, well, that just means a neural network with lots of layers, hence the deep and all those layers. They let it handle really complex data and see those patterns that regular networks just couldn't.
So, more layers equals more learning power.
Yeah, exactly. And the secret sauce is nonlinearity. So at each layer, you use a nonlinear function, QA, it's math, but think of it like this. If you only used linear functions, well, the whole network, it could be simplified, into just one linear function. And that would limit what it could learn. But nonlinearity, well, that lets the network learn curves and other shapes in the data. And that's how it understands the really complex stuff in the real world.
So what kind of things have these deep neural networks changed?
Oh, so much. I mean, think about image recognition. Now, machines can look at a picture and tell you what's in it. They're really accurate. Or language translation. You can translate languages almost instantly. And speech transcription. That's turning speech into text, and it's gotten incredibly accurate. And deep learning is even behind those game-playing AIs, the ones that beat the best humans at Go and chess, and in healthcare. Oh, it's helping doctors diagnose diseases, by looking at scans and patient data.
Wow, it's doing so much. So, what's next? I keep hearing about generative AI.
Yes, generative AI. This is a big one. Unlike the older AI models, the ones that just analyzed or classified data. Generative AI can actually create things like text, pictures, audio, even videos, and even synthetic data. It's like the AI went from being an analyst to being an artist.
Yeah.
Like an infinite inventor.
An infinite inventor. That's a good way to put it. So, how is it different, in how it works?
Well, the big difference is generative models versus discriminative models. Discriminative models, they're the ones that do things like image classification. Is this a cat or a dog? They learn to tell things apart, to see those boundaries between different things. But generative models, they learn the patterns in the data itself, like how the data was made in the first place.
Yeah.
And once they get that, they can make new data that looks just like the original stuff. So instead of just saying that's a dog, it can make a whole new picture of a dog.
Okay, so earlier AI was about understanding what's already there, and generative AI is about making new stuff.
Yes, exactly. Think about the usual machine learning process, right?
Uh-huh.
You train a model on labeled data, and it learns to predict things or classify things. Generative AI, well, takes that further. You can train what we call a foundation model on tons and tons of different data: text, pictures, code, audio, you name it, and it can be labeled or unlabeled, and that model, it learns a lot about the world from all that data, and then you can just tell it what you want, and it'll make something new.
And those large language models, the LLMs, those are generative AI, right? The ones that power like chatbots and stuff.
Yeah, absolutely.
Yeah,
they're a perfect example. They learn from huge amounts of text, like massive, and they learn all the patterns and how language works, so they can write like a human. You ask them a question, give them the prompt, and they give you back something new. Some of the big ones are PanelAM and LaMDA.
So when I ask it to write a poem or explain something complicated, it's not just copying something that's already written. It's actually creating something new based on what it's learned about language.
Exactly, and it's not just text. Generative AI can make images from text. Have you seen those? There's Stable Diffusion, for example. It can even make video clips and design 3D objects, all from just text descriptions.
It's amazing how fast things are changing. You mentioned transformers earlier and how they were important around 2018. What made them so special?
So transformers, they're a specific type of neural network, and they're really good at handling sequences like text. The older models, they They had trouble with long sequences. But transformers, they use this thing called attention. And that lets the model focus on the important parts of the input. It's like it knows what to pay attention to. And a transformer usually has two parts: an encoder, which processes the input, and a decoder, which creates the output based on what the encoder figured out. And this whole architecture, it really changed natural language processing, understanding and generating language.
And that leads us to prompts, right? Yeah. Those are important for using these generative AI models.
Right. A prompt is just a bit of text. You give it to the model, and it's like an instruction. It tells the AI what to do, what you want it to make. And writing good prompts, well, that's become a skill in itself. Because the better the prompt, the better the output. So
it's like we've gone from coding everything to just talking to the AI, and you said it's gotten easier to use.
Yeah, definitely. Now anyone can use generative AI. You don't have to be like a tech expert. There are these user-friendly interfaces, in your browser. You can make pictures, write stories, brainstorm ideas, all sorts of things. You just describe what you want.
Looking back, it's really something how AI has changed. So, what do you think were the most important things that made all this happen?
Well, there are three big things. First, you need data, lots of it, and it has to be good data, well organized. Often, it's not even about the algorithms. It's about having that data to train the models. So
the AI is only as smart as the information it learns from.
That's it. That's a great way to put it. The second thing is computing power. Those big models, like those deep neural networks, they need a lot of power to train. We're talking powerful CPUs, GPUs, and even custom hardware like Google's TPUs. Without those, it wouldn't be possible.
So much power to handle all that data.
Yeah.
And what's the third thing?
The third thing is, it's the algorithms. We need new and better algorithms all the time. The data and the computing power, they're like the fuel and the engine. But the algorithms, they're the steering wheel. They're how we make progress, how we build more intelligent AI.
So it's all three working together, right? Data, computing power, and algorithms. That's what took us from those rule-based systems to machine learning, and now to generative AI.
Yeah, exactly. And remember, AI, it's not just one thing. It's a bunch of different approaches and techniques, and they've all evolved over time. And understanding that timeline, well, that helps you understand the basics without getting lost in all the technical stuff.
This has been really interesting and helped me understand how all this fits together. So as we wrap up, what's one last thought you want to leave our listeners with?
I think AI, especially this new generative AI, it's like opening up a whole new world of creativity. We have these systems that can just keep creating new things, exploring possibilities, and maybe even driving innovation in so many fields. It makes you think, about what this infinite inventor means for the future. It's really exciting.
An infinite inventor. That's something to think about. And for those of you who want to learn more, we'll have some links for you. It's a really interesting time to be learning about AI. Thanks for joining us for this deep dive.